Okay, so I'm reading this, and I notice it's a much more difficult relationship now. And I got to be honest, they have a picture for it. I appreciate the picture, by the way. And, I'm seeing the x's are going between, looks like 0 and 3. And the y's look like they're going between 0 and some other number. I'm not sure what that is at this point. But what they want me to do is they want me to find the length over the interval between 0 and 2. Now, Grant, this might be a little confusing to you, and maybe I should be more clear about this. I'm going to say the x is on the interval between 0 and 2. So if I were looking at this over here, just kind of look at the picture. I'm going to say the picture, they want the length of arc between those two things there, all right? So I know I'm starting here and stopping there. So I got troubles already. My troubles are going to be, how do you want to do it? I'm going to say moving along the axis. Let's put that down for you. So I'm going to say it's going to go from 0 to 2. And this is length of arc, by the way. And this might get tough. Let's put this over here. And this would be dx over here. Now what goes on the inside? 1 plus dy dx quantity squared. Let's take a look at that. I got troubles automatically. I'm kind of looking at that. I want to just figure it out. And I notice that there's 9y squared is equal to x. And then it's x minus 3 squared. So I'm looking at the picture, certainly understand it somewhat. And I'm going to say y, or 3y, would equal x to the 1/2. Again, I'm looking at the picture to help me with this, and x minus 3. All right? Then I would divide both sides by 3. And what do you get? You would get y equals x to the 1/2. I'm actually going to multiply it out. And what would you have there? X, well, 1/2 plus 1 is 3/2. And then you get minus 3x to the 1/2 power. There's a reason for me multiplying it out, by the way. What do you get on bottom? 3. And I want to do dy dx now. And what do you get there? Looks pretty simple. You get, let's see, 3/2. I'll simplify this a little bit later. I'm going to reduce the exponent by 1. That would be 1/2. Then you're going to get minus 3/2. And I'm going to reduce the exponent by 1, so x to the minus 1/2. All right, it got problems now. And some of the problems just, maybe, I guess I got to simplify a little bit, right? So dy dx, I'm going to factor out the 3/2 and the 3. That would give me 1/2. I am also going to factor out x to the minus 1/2. And what would we left off with? Well, it looks like you'd be left off with x minus 1. All right, let's keep going. I got to square that. So dy dx squared. Well, that would be 1/4. X to the minus 1. And then you get x minus 1 squared. I'm going to simplify that a tiny bit. I'm going to say, 4x on the bottom. And then on the top you get x squared minus 2x plus 1. Now, yeah, it's a lot of work though, isn't it? I got to do this now. 1 plus dy dx squared. Now, it doesn't look that bad to do. It's going to be 4x. 1 is 4x over 4x, by the way. So you get x squared plus 2x plus 1. All right, let me write that down for you. You know what? I think I see something else there. I'll write that down for you. And x squared plus 2x plus 1 is just simply x plus 1 squared, and that's over 4x. All right? So let's take a look. And I notice I can write that up here. I'll write this down for you. It's x plus 1 squared over 4x. Oh, a lot of work getting there, wasn't it? So what I want to do now is I want to see if I can do that integration. I'm looking at it. The first thing I do is remove the root symbol. And I think I can do that. I'll write this down for you. 0 to 2. What's nice about this x plus 1 in the interval is positive. So I don't have to worry about absolute values, and x is positive. I should say non-negative. I don't have to worry about it. There is some issues here, but I'm not going to talk about those yet. And I'm going to say you get x plus 1 on top. And at the bottom, I get 2 root x. And that's dx. All right? So let's keep going. Kind of looking at the picture. Not a bad thing to be looking at. Hopeful to get through the integrations over here. And I'm still looking at it. 0 to 2. And I'm going to pull a 2 out. That's 1/2. And you get x over root x, which would be x to the 1/2 power. And then you get plus, well, it's 1 over root x, which is x to the minus 1/2 power. And now I'm starting to see this is a really simple integration. What do you get here? 1/2. And by the way, I'm doing the integration. Let's see, 1/2. The answer of x to the 1/2 is going to be x to the 3/2. I divide by 3/2 or multiply by 2/3. Okay, plus 1/2. I add 1/2 to, I add 1 to minus 1/2, which gives me 1/2. And I divide by 1/2 or multiply by 2. Limits of integration again are going from 0 to 2. All right, let's take a look. And you know, one step at a time, I'm seeing 1/3. And x to the 3/2 is just simply x root x. And then I get, let's see, I would get plus just the root of x. And that's going to be from 0 to 2. Well, this doesn't look too bad to do. What's nice about this integration, or the evaluation, is the 0 just, you know, the lower limit, 0, just makes that antiderivative disappear. So I'm left off with 1/3, 2 root 2 minus root 2. And I want to simplify to get a final answer over here. Common that would be 3. And what would you get there? Let's take a look. Oh, I'm sorry. It's not. It's plus sign. Sorry about that. You would get, let's see, 2 plus 3, 5 root 2s. Put a box on it. Indicate I'm done. Now, certainly, I want to look at the answer, and I want to make sure I'm getting the same answer they're providing. And I am seeing that. And certainly, there's work down there. Certainly a lot neater than what I did at my chicken scratch. But nonetheless, if you're listening, that's great. If you're not listening and just simply doing the work and verifying answers, that's good too. Or if you need a little crutch by looking at my area, my blue area for work, that's fine too. Whatever works for you. Thank you.